Good evening. Happy weekend. This weekend we will be studying 8.5, Flying in the Ocean, Rate of Change. We will start on the next page, so everybody go to page 426. All right, number 1 here says, suppose deep flight 1 is going to do a dive starting at sea level. Identify the independent and dependent quantities and their units of measure and find variables for these equations. Then write an equation to represent deep flight 1's depth. So there's about 4 parts there. Well, what is deep flight? You can turn back a previous page, read about deep flight here, and then we can go ahead and look at 1 and what we should do. So read that now. Press, pause, then play when you're ready.
It'll be negative.
All right, now, so our independent variable is going to be the time in minutes. The dependent variable is going to be the depth. And then we have D equals negative 480 times T, and T is time in minutes. D is depth. Use your equation to complete the table shown for the problem situation. Do not forget to define the units of
measures
and variables for this
situation.
All right, so the quantities here are time and depth. So we have time here under independent, we have depth here under dependent, and then the time is in minutes, that's the unit of measure, and then the depth is in feet. So up here when it was saying make sure you write their units of measure, we did time in minutes and depth, or you could say depth in feet, it doesn't matter. So then we have time, minutes, depth, feet. And then the variables, we define those up here, T and D. If you use something else, that's okay. So in the beginning, our lower bound, 0, 0 is the starting point. And then at 1, if I put a 1 in for T, it would be at negative 480 or down 480. Then 2 times 480 is
960.
So it would be negative 960, and then if we go to 3, we just continuously add 480. Go ahead and finish this chart and press play when you're ready. All right, you can go ahead and check your answers here and compare, and just remember that the negative means that's the depth down. At 7 minutes, what would be the depth of the submersible? 7 minutes. Well, we would just put a 7 here and go 1 more. And is this possible? Well, can it go down that far? That's just kind of a little fun question there. Let's turn to the next page. Okay, number 3 says, why does the table end at 6 minutes for this problem situation? So a second ago I said, could it go to 7? So why 6? And why not 7? Try number 3, number 4, and then press play when you're ready, and we will talk about unit of change. All right, the unit rate of change is the amount that value changes for every 1 unit that the independent value changes. So the unit rate of change, we're going to talk about that, and I want to make sure we have the answers here, 3 and 4. It cannot go 7 minutes because it would be too deep, and then the number before is 480 feet more, and the number after is 480 feet less. So one more time, let's read the unit rate of change. The unit rate of change is the amount that the value changes for every 1 unit that the
independent
value changes. So in this problem, what is the unit rate of change? 3.
The negative rate of change is negative 4. The unit rate of change is 480.
All right, so how deep would the submarine be after 2.5? So instead of 2, instead of 3, you could look back at your chart and say, all right, well, what was 2 and what was 3? And then find the middle, or you could take 2.5 and plug in for your equation. So go ahead and try that one. Let's try 6A, B, and C. Just know that 90 seconds is 1.5 minutes, 45 seconds is 3/4 of a minute, or 0.75. You could plug that in for your equation. We can check those in class on Monday. Do number 6, ABC. Go, go, go. All right, so now problem 2, deep flight 2, we're going to go to page 430, so skip some pages with me. Deep flight 1 can dive into a depth of 3,300 feet, and then and ascend to the surface at a rate of 600 feet per minute. So the surface, it can go up. Suppose deep flight 1 is going to ascend to sea level starting at its maximum depth, so all the way down at the bottom here was 0. This is the land. It goes all the way down to 3300. And I want to make an equation for it going up at 600 feet per minute. And I want independent, dependent, and quantities. Try number 1 now and press play when you're ready. The independent is the time in minutes, the dependent is the depth. In our equation, we're starting at negative 3,300, and then each time, each minute, will go up 650. So t times 650, or 1 times 650 plus the original, or 2 times, depending how many minutes. All right, and for homework to bring on Monday, let's do number 2, 3, 4, 2, 3, 4, and 6C. 2, 3, 4, and 6C. 2, 3, 4, 6C. Have a good weekend. Bye-bye.